This is the first lecture of Module 6. This module deals with synchronous motor drives. First of all, we will discuss the basic types of synchronous motors and the advantages of synchronous motors. Synchronous motor types. The commonly used synchronous motors are wound field synchronous motor, because the wound field synchronous motors are the synchronous motors with a field winding, and the field winding will be supplied from a separate power supply. Second one is permanent magnet synchronous motor, synchronous reluctance motor, and hysteresis motor. So in this module we will be discussing about wound field synchronous motors and especially permanent magnet synchronous motor drives. All those motors have a stator with a three-phase winding, which is connected to an AC source. For all these cases, the rotor will be different, but the stator will be the same. A stator with a three-phase winding will be there. And also the fractional HP synchronous reluctance and hysteresis motors have a single-phase stator. That is a special case. These are the commonly used types. Next, the permanent magnet synchronous motor types. So permanent magnet synchronous motors are of two types based on the rotor construction. First one is surface mounted type and the other one is interior or buried type. The surface mounted type is again classified into projecting type and inset type. First of all, we will discuss the case of a surface mounted type. First, we will see the basic features of surface mounted permanent magnet motors. They are easy to construct, they are less expensive, less robust compared to interior type rotors. Their mechanical strength is less. Not suitable for high-speed applications. These are the features of surface mounted permanent magnet motors. Now let's see the two different types of surface mounted motors. First one is projecting surface mounting type and the second one is inset magnet. So let's compare these two types. Here we can see that in the rotor, this is the rotor core as shown in the figure. This is the rotor core, and on the surface of the rotor core the rotor magnets, north-south magnets, are mounted. So it is known as projecting surface mounting because the magnets are projecting from the rotor surface. And in this case, this is the rotor core, and on the rotor surface the rotor magnets are inserted, or they are not projecting. They are inserted on the surface. So we can see that the surface of the inset magnet type synchronous permanent magnet synchronous motor is smooth. It is having a smooth surface. Rotor surface will be smooth, but here the rotor surface is not smooth. The rotor surface is irregular. These are the two different types of surface mounted permanent magnet motors. Next is the second type of permanent magnet motor, that is interior or buried type. Interior or buried type is nothing but the rotor magnets are buried or placed interior to the rotor core. This is the rotor core, and you can see the rotor magnets are not on the surface. They are buried or placed interior to the rotor core. Magnets are embedded in the interior of the rotor. Next, we will discuss the advantages of synchronous motors, both wound field motor as well as permanent magnet type motor. The wound field and permanent magnet synchronous motors have higher full load efficiency and power factor than induction motor. Next, wound field motors can be designed for higher power rating than induction motors. Since the air flux is not produced solely by the magnetizing current drawn from the armature, the larger air gap suiting the mechanical design can be chosen. That means for a synchronous motor, we can um, use a larger air gap. The ability to control power factor is an advantage at higher power levels. Operating at unity power factor minimizes the inverter rating. Permanent magnet synchronous motor has low losses and high efficiency. Because of low losses, it is possible to make motors with very high power density and torque to inertia ratios. These make them suitable for servo drives requiring fastest possible dynamic response. In the next session, we will discuss the basic operating characteristics of synchronous motors and how they are controlled. How the speed control is done. This will be discussed in the next session. Thank you.